Okay, and we're back again, and so let's continue on with where we left off for the attributes discussion. So let's talk a little bit about what attributes are. So attributes, remember I said yesterday when we talked about the mission statement of an organization that the nouns could be tables. All right, or in this case, what we're getting into is entities. All right, and that can be true, but there are some nouns too that will also represent attributes. So usually in the mission statement, the nouns of a mission statement will become entities. Usually, sometimes rarely they may become attributes. But when we start talking about some of that documentation that exists, or research, or however we go about analyzing the system, many of the nouns that we encounter along the way through our documentation will become attributes. And so basically an attribute is anything that is a property or some part of an entity or a relationship. So for example, if we're analyzing a system and we realize that we need to keep track of people, all right? So students, teachers, staff members, customers, users, whatever, right? Well, if we say, okay, well, a part of that customer is their name, okay? Part of their customer is their phone number. Part of the person is the email address, all of these kinds of things. Right, those are attributes that we're going to keep track of, right? And so most likely an email, phone number, name will not need to be its own entity, but will be an attribute of an entity. Okay. An attribute could have a domain. There could be a restriction on what is allowed to be a value. So for example, an email address, we might say we're going to only allow values that have the format of some string of characters, alphanumeric, followed by an @ symbol, followed by another string of characters, followed by a dot, followed by some other string of characters, right? Literally, the end of that is a domain, right? But the idea is straightforward here, right? That you have to have a set of allowable values that anything that does not fit into that domain, anything that does not conform to the set of allowable values will be rejected from the database. So for example, maybe a birth date, we might have the domain must be in the past, right? We cannot have a customer or a staff person who has a birth date that has not yet happened. We cannot set their birth date to be 2025, the year 2025, for example. Okay, there are all kinds of possible restrictions for what our domain could be. Right? We could have the difference between a simple and a composite attribute. So a simple attribute could be something that is composed of some simple component. Now it could be a string. It doesn't have to be like, what is it called? It doesn't have to be like a primitive type, although it oftentimes is, but it could be a string of characters as well. A simple attribute could be, let's say, for example, your name might be a simple attribute. Your first name might be a simple attribute. It's just a string of characters. Right. A composite attribute could be something that is composed of multiple parts. So for example, your address might be something that is a composite attribute, where you have an address of where you live, but that attribute consists of multiple components, such as city, such as mahalle, such as what else is there? Street name, street, number on the street. What is your building number? What is your DIDE number? What is which block, right? You know, A block, B block, right? Your postal code. So all of those parts, right? All of those parts put together make up your address. Now, the reason why we might want to have a composite attribute, because you might say to me, well, couldn't we just store the address as one long string of characters? And yes, you can. You can store an address as one long varchar or whatever, or text or whatever. But what if each of those parts of the address needs to have its own domain, right? So we don't want a postal code, like let's say somebody lives in Turkey. We don't want to have a postal code that does not exist in Turkey. We don't want them to use some postal code that doesn't exist. We don't want them to use a city in Turkey that doesn't exist. We don't want them to use a street that does not exist in the city that they claim to live in, right? I don't know if any of you have ever had to register through the Göç İdaresi, you know, for ECOMET. Those of you who are foreigners, like myself, have had to do this. And when I go to make an appointment to make an appointment to go for my interview at the Göç İdaresi, right? They ask for my address, but they don't just ask me to type in the string of a long string for my address. They say, what city do you live in? I click on Talia. Then they say, what is it? Ilçe, right? What, or Semt, what is it? Whatever. Murat Pasha, right? So I have to click on Murat Pasha, and then and then they give me this list of mahalles, and I click on my mahalle, and then they give me the list of streets that are in that mahalle, and I click on my street, and then they give me the list of buildings that are in, right? Because each of these parts of my address has its own domain, right? It wants to make sure that I don't put in some street that does not exist in the mahalle that I live in. Right? And so my address, as far as the Göç İdaresi system is designed and set up, my address is a composite attribute. It is composed of lots of different parts. Okay. All right. So that's how we define attributes. Oh, there's also some other differences. We can have a single valued attribute. So for example, in the OBS system, my name is a single valued attribute. I do not have multiple names. Now, I do have other names that people call me. I have a nickname, and I have other names that people call me, like my children call me Dad. They don't call me by my first name, right? But as far as the OBS system is concerned, I have one name. Right? I also have one email address. I also have one phone number, right? These are all things that I only have one of in the OBS system. So they would be a single valued attribute. We can also have what's called a multi-valued attribute, right? What if we want to have a secondary phone or a secondary email address or a second something, right? So a multi-valued attribute, we can say, this person can have between 1 and 3 phone numbers that we want to store. Okay, that would be an example of a multi-valued attribute. It's a single attribute, right? Attribute type with its own domains and what possible values it could be, but there could be more than one of them. Okay, and then finally, what's called a derived attribute is simply an attribute that represents some value that we get from some other set of values. So an example of a derived attribute might be for each staff person, we might want to find out how many properties are they managing. Right? So we might want to store an attribute that is they manage, you know, between 0 and 100 properties. Right? Now that derived attribute, the reason why it's a derived attribute is that we might not store that as well, we should not store that as its own value, independent. Like we just put whatever we want into that column, like a phone number, right? But it's has a meaning of something else. It has a meaning based on some other value. Okay, so it could be the number of rows that show up in the property table with that staff person's staff number in it. All right. An example of a derived attribute that every person has is your age. Okay, so like for me, my age is a certain integer value in years. Okay, everyone in this room, everyone in this chat, in this Teams meeting, whatever we want to call this, right? You have an age. It's an integer value that's derived, right? Your age is not something that just exists, right? It is derived from something else. What is it derived from? Like, how do we determine our age? Right, date of birth and what else? Right. Date of birth and something else. There's another piece of information. I can't just know your date of birth. Ah, right, exactly, Mustafa. Right. So if I know your birth date and I know what today's date is, I can tell how old you are. Right? So your age is based on two other values calculated. Right? So what most systems will do, is they won't, if they want to know someone's age, is they won't store it in their database as an integer value. They won't say an age column. They'll have a birth date column, and they will use that birth date column to determine someone's age. Okay, it's not always the case. There are some systems that do store just someone's age, but then it's having to constantly update. And we'll talk about here as part of this discussion, as part of this slide discussion, is the different ways that we can calculate a derived attribute. Okay, there's two different ways that we can calculate it, that we can store it and calculate it, and we'll talk about the two different ways we can do that. All right. All right. One more final discussion about particular attributes is, we've talked about these before, right? Is candidate key, primary key, and composite key. Every entity should have a primary key. I say should have. They don't always. Not every system has a primary key in all of its entities. But a well-designed relational database should have a primary key in every entity. Okay. And what we're using the primary key for is to uniquely identify every row, right? Every row that exists in our, ultimately in our table, but in our entity. Okay. We can have multiple candidate keys, but only one primary key. And a composite key is anytime a candidate key consists of two or more attributes. So we can have two columns, right? When we get to our tables, we can have two columns that together uniquely identify a row that neither column on its own uniquely identifies a row, right? But the two together do that. We'll talk about that. We'll give some examples of that. All right. So if we were to have an ER diagram that included both staff and branch, along with their attributes, it might look something like this. Okay, Tadana, so a candidate key, let's see, a candidate key is any column or set of columns that uniquely identifies a row. A composite key is a candidate key that that has more than one column? Okay, so let me kind of go back to that slide for a second, because that's a good question. All right, so here, notice that a composite key is simply it is a candidate key that has more than one column, more than one attribute as part of it. A candidate key is anything that uniquely identifies a row, that uniquely identifies a record. All right. That minimally uniquely identifies. So what that means is that a candidate key is any column or set of columns that no subset of those. So if we had columns, let's say we had column A, B, C, and D, and A and B together uniquely identify a row, but A on its own uniquely identifies a row, then A and B together is not a candidate key because there's a subset that uniquely identifies the row. Okay. So a composite key is a candidate key. A candidate key is not necessarily a composite key. A candidate is a hard word to say. Candidate key could exist of one column only, of one attribute only. Right? If it does, then it's not a composite key. If it consists of more than one attribute, then it is a composite key. And then simply a primary key is the candidate key that was selected. So a table entity may have more than one candidate key possible. And if it does, we choose one of them to be the primary key. Okay. So that should be the distinction there. All right. Okay. So here, all right, we'll have the staff and the branch entities. Remember our relationships where the branch has staff and a staff manages a branch. Here we can list our attributes just like in UML. Right? Just like in UML. We note the primary key for each. And then these are the other attributes that exist. Here's how we would identify a derived attribute, where we say total staff. So the total staff that they are managing, if this is a manager. Right. So the reason why we would note it like this instead of just saying, hey, this is an attribute and it just happens, is that this attribute might not be a column in the staff table once we make tables. We may calculate it some other way. Okay. Branch. This is how we would note a composite attribute, saying this is an address and these are its parts. And this is how we could note a multi-valued attribute, saying that a branch may have 1 to 3 telephone numbers. Okay. So this is how we could represent the entity and relationship diagram for a staff and branch. Okay. A couple other terms that you might want to know is in a relationship, you can have a strong and a weak entity. Right? The strong entity is something that does not depend on the other for its own existence. A weak entity type is one that basically it doesn't make sense for it to exist without the strong entity type existing. Okay. An example, let's see. Example in the university, right, is if you had a relationship between department and teacher. Okay. A teacher, and as far as the university is concerned, this teacher, it would be considered the weak entity type because the teacher's existence depends on the department that they belong to existing. All right. Department, if the department were to go away, the teacher would go away. In the same way, in this next example, we'll talk about client and preference, right? If a client states a preference, the client is strong, the preference is weak. If the client goes away, their preference, who does the preference belong to if there's no client? Right? So back to our department teacher example. Imagine if the whole department, computer engineering, were to suddenly disappear from our university. I wouldn't be here anymore, would I? Right? This course, would that be a bad thing? Yeah. But if I were to go away, if I were to get, hit by a bus, or if I were to, I don't know, get very ill and have to go to the hospital, or for whatever reason was no longer at this university, which I hope does not happen because I really like you guys and I really love working here. All right. But if I were to go away, the department would be just fine. The department would stick around, wouldn't it? And that's why for that relationship, department would be considered the strong entity, teacher would be considered the weak entity. Basically, the concept is if the one going away would automatically mean the other would have to go away as well, that one's the strong. If this one going away or changing could change, right? But if this one going away has no impact on this one, then this one is the weak. Okay. All right. Let's see. A relationship can also have attributes. Not just entities have attributes. A relationship can have attributes. What we'll see is this normally means something about the type of relationship this is. We'll talk about that in the next section, all right, later this morning. But let's say you have a newspaper entity that we're keeping track of newspapers that we advertise our properties in. A property for rent is also something that we track. And we want to say, okay, the newspaper advertises our property. We might want to keep information about that because notice this date of advert. When did we push this advertisement? What was the cost? How much did the newspaper charge us for that advertisement? We might want to keep that information just in case we might consider using different newspapers later. We might want to keep track of which newspapers cost more than others, or really even we might even keep track of in some other way which newspapers had more impact on getting our properties viewed and stuff like that, right? But the idea is this date of advert and cost, it doesn't make sense to go into the newspaper entity because this may change. It may be the same newspaper on a different date, cost a different amount. All right, and we don't want to keep that here because then we'll have all these multiple. Okay, newspaper. What's the newspaper? What's a good newspaper here in Turkey? I don't read the newspaper very often. Right. But let's say the daily news, right? the Daily News newspaper. On such and such a date, it cost you 100 lira to advertise our property. Then that same newspaper, 2 weeks later, they charged 120 lira to advertise a different property. All right. We don't want to keep having a new record every time, a new row every time into the newspaper entity every time we advertise something. All right. And in the same way, we don't want to put it into the property in multiple newspapers. So we don't want to keep that information in the property for rent entity. We represent that every time we put an advertisement in a newspaper for a property, we have attributes associated with that advertisement. Okay. What you're going to see is that generally when a relationship has attributes, that means this is a specific type of relationship we'll talk about in just a moment when we talk about relationship types. It also will mean that these attributes will have to be stored somewhere, and we will see how that happens. Okay. Another example of a relationship that might have attributes. We might have a student takes a course, right? Like you take CSE 204. I hope you guys all take CSE 204 because you're sitting here today. And if you're not enrolled in CSE 204, we welcome you and thank you for listening in. But if you're not registered for this course and you think you should be, you should have taken care of that already. But I welcome anybody who wants to listen in on this course, right? So a student takes a course. Well, what type of attributes might be associated with a student taking a course? What do you think? What are some attributes that might come along with a student taking a course? Would that last name and first name, would that go in the relationship or would that be in the student? So with those, I think those attributes, last name, first name, student number, I think they would more likely go here in the student table, right? In the student entity. It's more specific. Your name doesn't change based on what course you take, right? Your number doesn't change based on what course you take, right? Remember, these attributes represent a relationship between two existing things. So a newspaper has a name. A newspaper has an editor. A newspaper has an office building or whatever, you know, an office, right? A property for rent has a property number, has an address, has an owner, right? These are all things that exist in the property. When we advertise a property in a newspaper, there's a date that we advertise it and there's a cost. These things may be changed, right? We may advertise this a property for rent in a newspaper on a different date, right? So think about what type of information we might represent for a student taking a course. The semester, yeah, right? You might take CSE 204. Which semester was it? Okay. There's a very important attribute that would go along with a student taking a course. So you take this course in the spring of 2021. What's an important attribute that will come along with you taking this course? What do you think? It's probably the most important piece of information you want to get from this course. Probably the most important information to you. Degree like diploma, like when you graduate? Is that what you mean, Ur? Yeah, right, Tirana, that's what I'm thinking is pass or fail, right? But maybe more specifically, I was thinking grade, right? So when you take a course, you get a grade, don't you? All right. Remember that this is distinctive to a particular crossing of the, in this case, in this example, the newspaper advertising a property for rent. It happened on a specific date. It cost a certain amount. So when a student takes a course, what is specific to that happening? What's specific to a student taking a course, right? Yeah, he may have. That's what I'm thinking also, Tadana. So when you take this course, what's specific that's only to you and this course? The schedule? Humaira, I mean, that's a good idea, but that would be something, don't you think, particular to the course, not just to you taking the course, right? Unless, Humaira, are you attending the course differently from other people? Yeah. So maybe some of you are. Actually, some of you are attending this course differently than others because you have course conflicts, and so maybe that would be something. But more particularly to specifically you, more specifically to you taking this specific course, you get a particular grade, right? The grade that you get for this course, you cannot use that grade in another course. Some of you may not want to use the grading you get in this course on another course. Some of you may prefer it, right? All right, so that's an example of how an attribute, sorry, a relationship may have attributes associated with it. All right. Okay. We do want to talk a little bit about what's called structural constraints, multiplicity, and we will also talk about cardinality and can't remember the other word on the other side of cardinality. What is it called? Anyway, we'll get to it. All right. We will talk about multiplicity. So there's three types, generally three types of binary relationships, right? And so basically just like UML, we talked about these types of relationships there as well, okay? They can represent constraints that exist between two different types of relationships. So let's just get into it. Binary relationships, we can have three types: one-to-one, one-to-many, and many-to-many. Okay, a one-to-one relationship between two entities simply means that if there exists a record or a row on one side, there exists only one on the other side. Okay. One-to-many means if there's one on one side, it could have many on the other side. And many-to-many could say there's lots of crossing that goes on. There could be many on this side, many on this other side. A one-to-one relationship might be if we said a user let me think. A one-to-one relationship might exist between a department and the chair of that department, the head of that department, right? is that if their department exists, they must have one and only one head of that department. For us, it's Meli Hoja, right? And if he is the head of a department, he can only be the head of one department. We can't have Meli Hoja be the head of both the computer engineering department and the electrical engineering department and the tourism department, right? If you're the head of one department, you can only be the head of one department. That could be a one-to-one type of relationship. A one-to-many relationship could be an owner of a property can own many properties, but a property can only have one owner. Okay. If a property exists, it can only be owned by one. We cannot have multiple owners, maybe. Might be an example. Right. A many-to-many relationship. Well, the example that I just gave a moment ago about the students and the courses. A student can take many courses in a semester, right? Right. You guys probably take more than one course this semester. All right, so a student can take many courses. A course can have many students. There's lots of you in this meeting right now. To be exact, there's what, 9, 10, 12, 13, 14 plus 3, 23. So there's 23 of you here. 24 if you count me. All right. So, and that only represents a portion of those of you who are enrolled in this course. Right? So a student can take many courses. A course can have many students. Okay. Right. So one way we can represent these relationships, if we're trying to get down into the finer understanding of it, is what's called a semantic net. All right. So the idea is we say these are some examples of staff that exist. This is how they are related to the branches, right? Now notice one side of this might have staff members who don't have a relationship here, who don't have a branch that they are managing. What that represents, what that's telling us is that this staff person isn't a manager. They work at a branch, but they do not participate in the manager's relationship. Okay, so this staff person does not participate in the manager's relationship, so they don't have a branch over here that they are part of. Now they work at the branch, but that's a different relationship. This one is we are only analyzing the manager's relationship. So this staff person manages this branch. This staff person manages this branch. So we would call this a one-to-one relationship. This is the same thing as the chair, the head of a department, and the department that I used in the previous slide example. Okay, and in the same way, so this would be Meli Hoja here. SG5 would be like Meli Hoja. He is the head of the computer engineering department. Me, I'm over here. I'm not the head of a department. Right? I work in the department, but I don't have a manager's relationship. I don't have a chair of or head of or whatever you want to call it. I don't have that type of relationship with our department. Okay, so the way we'd represent that, it's a one-to-one relationship. We could say a lot of different statements about this. So each branch is managed by one member of staff. A member of staff can manage 0 or 1 branch. So this is what's called participation and cardinality. Is that right? Yeah. Yeah, participation and cardinality. We'll talk about those other finer details in just a moment. But the way that we would read this is a one-to-one relationship. We call this a one-to-one because of the number on the right of these two. The number on the right is 1 here, it's 1 here, which means this is a one-to-one relationship. A staff is not required to manage a branch. That's what this 0 means. But a branch is required to have a manager. That's what this 1 means. Okay. Each branch is managed by 1 member of staff. Must be 1 and only 1. A member of staff can manage 0 or 1 branch. The way that we would say is that participation is required on the branch side. So the branch must participate in the staff relationship, in the manages by staff relationship. Right. Branch must participate. Branch must have a staff person as its manager. But the staff participation is optional on the manager's relationship. Just because a staff person exists does not mean they must manage a branch. I don't manage a department. I'm not the head of a department. I don't participate in the head of department relationship. Okay, and that's okay. I don't want to. And I don't want to be the head of the department. No way. All right. Okay. All right. So this would be how you would read this. Okay. Well, what about a one-to-many relationship? A one-to-many relationship might be represented like this. Staff oversees different properties for rent. Notice we have a lot of non-participation here, don't we? We got non-participation on both sides. We have SG5. If you think back to the couple of slides ago, SG5 was a manager, right? So managers may not always oversee properties. All right. Okay. So SG5, staff doesn't have to participate in the oversees a property for rent relationship. We might have staff people that don't oversee any properties. We might have staff people that oversee more than one property. We might have staff people that oversee only one property. We might have properties that aren't even overseen. Look, properties don't participate. Why is this property not overseen by someone? There could be lots of reasons. Maybe the person who was overseeing it got fired or died, or maybe this is a new property that just got put into the system and hasn't been assigned to anyone yet. There's all kinds of reasons why this property might not be overseen right now. Notice that participation not required on either side. But if a property is overseen, it's only overseen by one person. If property is overseen, it's only overseen by one person. Here, this one's only overseen by one person. Okay. The way we would represent this using a binary relationship. A staff oversees properties. Each property for rent is overseen by 0 or 1 member of staff. Each member of staff oversees 0 or more. Notice this star. This star means there's no limit. Okay, we're not putting a limit on here. We could say only 100 or only 10 or something like that. All right, we can put it, but star means whatever, however many they want to oversee. Okay. Notice here again, participation not required on either side. So a property doesn't have to be overseen, but if it is overseen, it can only be by one staff person. A staff person does not have to oversee any properties, but if they do oversee a property, they can oversee as many as the system will allow, or as many as properties as there are. Whatever. But we would call this, overall, we would refer to this as a one-to-many relationship. Okay. One more final overview of these relationships we'll talk about is the many-to-many relationship. and we will get to, we will finish up this many-to-many initial discussion, and we'll end there for today, because I think I've given a lot of information for you guys today, a lot of overload. So we'll break off after this. But this many-to-many relationship exists between the newspaper advertises property for rent. You could also say the previous example, we might look at something similar to this for students take courses, right? But here you have newspaper, Glasgow Daily advertises many properties, can advertise many properties. A newspaper could advertise one property. A newspaper could advertise one property. Property for rent could be advertised in only one newspaper. A property for rent could be advertised in multiple newspapers. A property for rent could be advertised in one newspaper. A property for rent could be advertised in no newspapers. Now notice over here, there's no newspaper over here, right? There's no newspaper over here that doesn't advertise a property for rent. Why do you think that is? Why do you think that we don't have a newspaper over here that doesn't advertise a property for rent? Because I'll tell you, when we get to there, when we look at how this would be represented in an ER diagram, participation on the newspaper side is required for our system. Why do you think that is? Why do you think we require participation by the newspaper? Are we forcing newspapers to always advertise our properties? Do we have that power over the newspapers? What do you think? Tough question, huh? Let's make that a take home. I know you guys, many of you already are at home. Oh, wait. Ah, yeah, okay, good. Fatih Furkan. Yeah, Furkan, if we have a newspaper in our system, it means we've most likely advertised. It's because we've advertised with them. Why would we store information about a newspaper if we have not advertised using them? Right? It would just be extra information, because it's like, it would be like me keeping information about a course that I've never taught. Right? Why would I keep that information? Why would I have any information about grades or anything like that for students in courses I've never taught? Right? That would have no need for that. Right? So exactly. So the participation is required over here, not because we force every newspaper in the world to advertise our properties, but because if we have not used a certain newspaper, it does not make sense for us to keep information about them in our database. It would just be extra space taken up that we don't need. Yeah, good. Good thinking. But a property, we want to keep information about properties even if we have not advertised them. Okay, so the way we would represent this relationship, we have a newspaper, we have a property for rent, we say a newspaper advertises our property for rent, okay, and we can say a newspaper advertises one or more properties for rent. One Participation is required on the newspaper side. The newspaper must participate in this relationship. That's what this one means. It can participate as many times as we want. All right, star. A property for rent is advertised in 0 or more newspapers. Properties don't have to participate. They don't have to be advertised. All right. But if they are advertised, they can be advertised in as many newspapers as we want. Okay. And again, the general term we would use for this is called a many-to-many relationship. Okay. All right. So we've talked about the one-to-one, the one-to-many, and the many-to-many. We've kind of given a bird's eye view, an overall view of it. Right. Introduced it. We'll get into more details involving entities and relationship types and some of the rules we can put on relationships in next week's classes. Again, we will have a quiz on Monday and we will not have a live lecture on Monday. So you'll have a quiz during the class time, during the Monday class time. But you will not have a live lecture. I will upload a video recorded lecture because I'm going to try to experiment with trying to do something for that. Okay. All right. Are there any questions before we dismiss? Any comments or questions? In 3, 2, 1. Okay. All right. Well, thank you guys for attendance and thank you also for some comments here. Very well done. And I will see you guys live. I'll see you on Tuesday. And other than that, have a good weekend or have a good rest of your week. It's not weekend yet. It feels like it should be, doesn't it? And I'll see you next week.